Welcome to qnawire.
All right, we've got to draw a couple of mechanisms. The first one is the reaction of acetyl chloride with water to form acetic acid. The first thing that's going to happen is the lone pair of water is going to attack the carbon-carbon, and the double bond is going to swing up onto oxygen to give us what's known as our tetrahedral intermediate. Get a negative charge on oxygen, and we have this positively charged water. All right. Next, we often see the double bond pushed down and kick off chlorine. Yielding protonated acetic acid, at which point a second molecule of water will come in, or we could say a chlorine comes in, although the second molecule of water coming in is a little more valid, if you ask me. In terms of basicity, remember, chloride ions are not very basic. In either case, the acetic acid will get deprotonated to yield carboxylic acid. Another way we may see this is that once we get to this tetrahedral intermediate, and if you ask me, this is slightly more valid. Once we get to the tetrahedral intermediate, what we see is the transfer of a proton from the water molecule either directly to the alkoxide, or even more accurately, we can have a second molecule of water come through, deprotonate, and then return H3O plus, at which point the alkoxide will deprotonate that. Finally, now this lone pair will push down and kick off chlorine. And at this point, theoretically, another water molecule or chlorine can come and deprotonate to give us our final product of acetic acid. So the first one is kind of quick and dirty. Whereas the second one is more accurate. Okay. And now we've got to show the mechanism for basically the same thing, but with acetyl bromide, methylamine, to form N-methylacetamide. Okay, so we'll start with acetyl bromide. And we're going to have our methylamine. Come and attack. Carbon-carbon, lone pair swings up, or double bond swings up onto oxygen as a lone pair. We get our tetrahedral. And once again, we've got this positively charged group here. And we can show the proton transfer one of two ways. We can show it directly, slightly less accurate, but depends on your teacher. And now we've got an OH, as well as our methylamine. And at this point, lone pair on OH swings down, kicks off the bromine to form the amide, which is still protonated, positively charged. At which point, bromine can come in, deprotonate. To give us our N-methylacetamide.